Okay, today we're starting a new chapter, chapter 1 called Problem Solving and Critical Thinking, which is a lot of what we're going to be using for the rest of the year because we're going to concentrate a lot on our algebra skills. So the first section we have is Inductive and Deductive Reasoning. Now keep in mind that math involves the study of patterns. In everyday life, we frequently rely on patterns and routines to draw conclusions. So they give you an example here. The last 6 times I went to the beach, the traffic was light on Wednesdays and heavy on Sundays. My conclusion is that weekdays have lighter traffic than weekends. This type of reasoning process is referred to as inductive reasoning, sometimes referred to as induction. Okay? Now, this inductive reasoning is the process of arriving at a general conclusion based on observation of specific examples. Um, One of the ways that they prove that whatever conjecture or conclusion that you come to does not hold is they find a counterexample. So keep that in mind when you come to conclusions using inductive reasoning, that this is a possibility. For example, find a counterexample to show that the statement, the product of two two-digit numbers is a three-digit number. So you might go through and say, well, 10 times 10 is 100. That's a three-digit number. 20 times 20 is 400. That's a three-digit number. Let's go higher. What if I went 50 times 50, and that equals 2,500? Oops, not 25,000. 2,500. And that clearly is not a three-digit number. So we have given a counterexample to show that the statement is false. Okay, so the rest of this time we're going to spend looking at patterns, and I'm going to try to help you break it down so that you can find the patterns, because that's what's going to help you be successful. So identify the pattern in each list of numbers, then use this pattern to find the next number. So looking at 3, 9, I didn't mean to do that. 3, okay, my airliner's going to go wacky on me. Let's see if we can fix that. 3, 9, 15, 21, 27. So anybody determine a pattern, hopefully you can see that these are all multiples of 3. This is 3 times 1, 3 times 3, 3 times 5, 3 times 7, and 3 times 9, which means the next one would be 3 times 11. And 3 times 11 is 33. All right, let's look over here. 2, 10, 50, and 250. Keep in mind, if the numbers are going up, then we're going to be hopefully multiplying or adding. So you look at the difference. That's adding 8. That's not adding 8, so it's not going to be adding. 2 times 5 is 10. Times 5 is 50. Times 5 is 250. Times 5 is 1,250. So each time we're multiplying by 5. All right, look at C. In C, we have 3, 6, 8, excuse me, 3, 6, 18, 72, 144, 432, 1728. Kind of an odd. And one of the things to start doing, as you heard when I did this, okay? 3 times what is 6? 3 times 2. 6 times 3 is 18. 18 times 4 is 72. So you might have to get your calculator and see that. Is that 72 times 5? That's not 72 times 5, but it is 72 times 2. and then 144 times 3, and then 432 times 4. So what's going to be the next one? Yep, it's going to be 1728 times 2, which is going to give us 3, 4, 5, 6. Lovely announcement. Okay, in this next one, we have 1, 9, 17, 3, 11, 19, 5, 13, 21. So I look at those and I say, well, I'm adding 8 and I'm adding 8. And then I'm not adding 8. But then I am adding 8 and I'm adding 8, but I'm not adding 8. But I'm adding 8 and I'm adding 8. So something about these other ones that, let's see, they stick out. So I had the 1 and the 3 and the 5. So if I go back to that, 1, I pick a number 1, I add 8 to it twice. Then I go to 3, add 8 to it twice. Then I go to 5, add 8 to it twice. And hopefully you can see the next number is 1, 3, 5, 7. Okay, some more patterns. Okay, they're all different. All right, and the more you look at these patterns, the easier it's going to be for you to determine what the pattern is. Okay, let's look at this one. We've got 1, 3, 4, 7, 11. So again, it's going up. I'm going to start with adding. So I'm going to say, well, we added 2. I added 1. I added 3. I added 4. I added 7. I added 11. I added 18. Huh. Well, in case you don't notice, except for this number right here, these numbers are the same as those numbers. For example, 3 plus 1 to get to 4, so that's the number before it. 3 plus 1 is 4. 4 plus 3 is 7. 7 plus 4 is 11. 11 plus 7 is 18. 18 plus 11 is 29. 29 plus 18 is 47. And 47 plus 29 is our answer of 76. All right, now let's look at this one. Again, my numbers are going to go up. So I'm looking at, let's see, I added 1. I added 2. I added 4. I added 8. I added 16. I added 32. I added 64. So what am I going to add next? So you are looking for some pattern here, and hopefully you notice 1, 2, 4, 8. Each of these numbers you get by multiplying the previous one by 2. So 64 times 2 is not 218. It is 128. So that when you add those together, you're going to get 257. Okay? So let's go. Describe two patterns in this sequence of figures. Use the patterns to draw the next figure in the sequence. Okay? So keep this in mind. Whenever you see shapes, sometimes it can throw people off. Sometimes people think it's a heck of a lot easier. To describe two patterns in the sequence of figures. So look at the actual top part of the figure, and you see that the top is going between, let's say, the top alternates between a square and a triangle. So the next figure, square, triangle, square, triangle, square, that's supposed to be a square. And the bottom, what's happening with the bottom here? The bottom, 1, 2, 3. 1, and it just comes out from the middle. So I'm going to draw my little shape as is. The bottom goes 1, 2, 3, 1, so forth and so on. But one of the most important things I want you to see about that is that basically breaking down, when you have a visual picture, break it down to the small parts, and it should help it make it easier for you to figure out what the pattern is. Okay, the other kind of reasoning we have is deductive reasoning, and this is the process of proving a specific conclusion from one or more general statements. And y'all used it a lot last year in geometry and used theorems. Okay, so they've given us a procedure. Select a number, multiply it by 4, add 6 to the product, divide this sum by 2, subtract 3 from the quotient. So they want us to do that for 4 numbers, and when we're going to write a conjecture that relates the results of this process to the original number. So I made a chart to help simplify the process for us. And I'm just going to pick some numbers. I'm going to pick 3, 8. I want odd and even. 1, 2, 3-digit numbers. Okay. And I'm going to go down. 3 times 4 is 12. 12 plus 6 is 18. 18 divided by 2 is 9. And 9 minus 3 is 6. And we'll go to the next one. 8 times 4 is 32. 32 plus 6 is 38. 38 divided by 2 is 19. And 19 minus 3 is 16. So you might see a pattern. We're going to keep going. 15 times 4 is 60. 60 plus 6 is 66. 66 divided by 2 is 33. And 33 subtract 3 is 30. We have 100. 100 multiplied by 4 is 400. Plus 6 is 406. Divided by 2 is 203. And subtract 3 is 200. So they're asking us to make a conjecture from this beginning number to this ending number. I started with 3, I ended with 6. I started with 8, I ended with 16. If I started with 15, I ended with 30. And 100, I ended up with 200. So hopefully you can see from that that the result is, let me hear you say it. You got it. The result is 2 times the original number. Now, let's look at that in a general sense. Okay, part B, this is part B. Use the variable n to represent the original number and use deductive reasoning to prove the conjecture in part A. So we're picking any number. Okay, we multiply n by 4. That's 4n. We add 6 to it. That's 4n plus 6. If we divide that by 2, that means divide this by 2. Divide that by 2. And then subtract 3 from this. So if I have 2n plus 3 minus 3, I'm going to end up with 2n. And 2n is exactly what we just said we got right there. So we showed that we got twice our original number. Now that's the end of patterns. One thing I do want to emphasize, and it's in your book, the best way to learn math is seeing the solutions to examples and then doing the exercises. Some of y'all hadn't picked up on that yet, so I really hope that you will actually perform the solutions by yourself and get in the habit of working exercises every day. Because the more time you spend solving exercises, the easier the process becomes, and that's why we're doing our classroom the way we're doing it. So if you have any questions, come see me, and I will see you in class.